In this video, our goal is to consider the basic rules of probability. You must have observed from earlier videos that we have established that whenever you compute the probability of an event, it must be greater than or equal to 0, but at the same time, it must be less than or equal to 1. This is the first rule of probability that I would like to reiterate and emphasize. The next one that feels almost new is that if you consider the sample space of an experiment and you look at the different outcomes and you compute the probabilities for the different outcomes, if you sum up all the probabilities of all the outcomes, it must never exceed 1. It must be equal to 1. So these two rules of probability lay the foundation or groundwork for what is called a probability model. You see, a probability model will list all the possible outcomes. Say in this example, the outcomes of the experiment of having a baby pick one of these different types of colored marbles, and we cannot tell which one the baby will pick in advance. So that's an experiment. But we can list out all the possible outcomes, and based on previous data collected, we can list the respective probabilities or likelihood that each of these colored marbles will be picked by a baby. So that brings us to the question. This table, where you have the different outcomes and their respective probabilities, does it represent a valid probability model? In other words, does it obey the rules of probabilities as specified up here? Well, all I need to do to answer that question is to check if each of the probabilities is a number between 0 and 1, 0 and 1 inclusive, and that appears to check off. So rule number one checks off, is satisfied. But what about rule number two? For rule number two, the sum of all the probabilities must be equal to 1. This is a good point to grab your calculator and add up the probabilities. And sum of all probabilities, when I computed it, was equal to 1. So since both rules are followed by this table here, we can say that this table is a probability model. All right, here's another example where we consider a table to the right and we look at the different colors and we look at the different probabilities. Do you think this is a probability model? Well, if you consider the outcome green, it is associated with the probability negative 0.4. That is not a number between 0 and 1. That is a negative value. That violates the first rule of probability that every probability must be a number either equal to 0 or greater than 0, and at the same time equal to 1 or lesser than 1. In other words, it's not a number between 0 and 1. So in this case, we can say that this is not a probability model. All right. With that said, what do we use probability models to do? We can use it to compute the expected value and the standard deviation of a random variable of interest. In this case, we consider an example. Suppose Nancy has classes 3 days a week and she attends classes 3 days a week 80% of the time, 2 days of the week 15% of the time, 1 day a week 4% of the time, and no days at all in the week 1% of the time. Well, in this illustration, our variable of interest, what is that quantity of interest, will be the number of days that Nancy attends classes weekly. That appears to be the subject of this scenario. Now, if I let x represent the possible number of days that Nancy can attend classes weekly, which is a variable, of course, from week to week, I can tell that there are days when she does not attend classes at all during that week, or there are days when she attends only once a week, there are days when she attends only 2 times a week, and there are even days when she attends classes all 3 days of the week. So X, the number of days she attends classes a week, could be either 0, 1, 2, or 3. So these are possible outcomes on a weekly basis. Now we would like to match each of these possible values or this possible number of days with how frequently they occur or how likely they are to occur. From what we are told, she attends classes no days, 0%, 0 days, 1% of the time, that is 0.01. What about 1 day a week? For 1 day a week, she attends 4% of the time, and for 2 days a week, 15% of the time, and for 3 days a week, you have 80% of the time. Considering this table, does it qualify as a probability model? Let us check. It will need to satisfy the two rules of probabilities. And as we might have observed, each probability here is a number between 0 and 1, and the sum of all the probabilities is equal to 1. So this table definitely qualifies as a probability model. With that said, let us look at a new term called the expected value of the variable or quantity of interest. In this consideration, we're interested in the number of days Nancy attends classes weekly. Under the assumption that this probability model continues to apply for an infinite number of weeks, well, we can answer the question, on average, how often does Nancy attend classes weekly? The answer to that question will be to find the expected value of the number of times she attends what classes weekly. How do we find the expected value using the probability model? This is what you do. You simply take each of the respective values, x, we multiply by their respective probabilities. For instance, 0 multiplied by 0.01, that will give us 0. The next one, 1 multiplied by 0.04, that will give us 0.04. I'm going to erase a couple of lines here to bring some clarity here. Okay, and then next will be 2 multiplied by 0.15, that will be 0.30. And next will be 3 multiplied by 0.80, that will be 2.40. Now, the addition of all of these results here would be the expected value of the number of times Nancy attends classes weekly. So that will be 0, that will be 0, 0 0.04, 0 0.30, and 2.40, excuse me, and 2.40, and that will give us the value of 2.74. So in the long run, if this probability distribution continues, the expected value of the number of times Nancy attends classes on average weekly will be 2.74 times weekly. Based on this too, we know that the number of times she attends classes weekly varies from one week to another. Well, if it varies from one week to another, what is the average variation? That will lead us to what we call the variance and the standard deviation of the quantity of interest, which is the number of times she attends classes weekly. How do we find the variance of the number of times she attends weekly? There's a simple rule that says that we have to take the expectation of x squared minus the mean value, the expected value all square. if this looks like an interesting formula, what you might notice quickly is that we're already halfway through the solution. We already found the expected value, which is 2.74. So, as far as this formula is concerned, the only thing we need to find is this guy minus the result we have previously, which is 2.74 squared. So how do we find expected value of x squared? We go back to the table. You will notice that when we had the expectation of just x, we were using just x to multiply the probabilities. If we are told to find the expectation of x squared, it means we'll first find our x squared values. Our x squared values will be the square of each of the x values. 0 squared is 0, 1 squared is 1, 2 squared is 4, and then 3 squared is 9. Okay, then to find your expected value of x squared, we will say each x squared value multiplied by its respective probability. So what does that mean? The x squared values we have gotten is 0, 1, 4, and 9. We're going to say, for instance, 0 multiplied by the respective probability, which is 0. And then next, it will be 1 multiplied by 0.04, its respective probability. And then next, you have 4 multiplied by 0.15. And lastly, 9 multiplied by 0.80. This will give us 0.6. And this will give us about 7. This is about 7.24 there, about 9. Let me grab my calculator. So you have 9 multiplied by 0.8. So that'll be 7.2, correct. And the sum of all of this, that is your expected value of x squared, which is 7.84. We're going to drag that result back into this formula here. And so what we need is, so we have 7.84 minus 2.74 all squared, which will give you 0.3324. This is the variance of the number of times that Nancy attends classes weekly. Next, as a derivative of the variance is the standard deviation of the number of times she attends classes. That will be the square root of the variance of x. That will be the square root of 0.3324, the previous result we have, and that should give us about approximately 0.5765. This is the standard deviation of the number of times Nancy attends classes weekly. These two measures, as you might recall from earlier classes, helps to measure the spread of the number of times she attends classes relative to the mean. Here's another example to consider in a business environment. This talks about a term life insurance policy which will pay a beneficiary a certain sum of money upon the death of the policyholder. And these policies have what premiums that must be paid annually. Suppose an 18-year-old male buys a $250,000 one-year term life insurance policy for $350. According to the National Vital Statistics Report, the probability that the male will survive the year is 0.998937. Our interest here is to compute the expected value of this policy from the perspective of the insurance company. To do this, we take the following steps. A. For this experiment, this male may either survive the year or not, so we do not know in advance. But what are the two possible outcomes here for an 18-year-old male who buys this term life insurance policy? Well, two possible outcomes. Either survive or death during the year. Two possible outcomes. And that will be either survival or death. These are the outcomes of interest. Well, What is the random variable here? That is the major consideration as far as the insurance company is concerned. The insurance company is in business to make money, so and they also consider how much claims they pay out relative to how much they get. As far as the insurance company is concerned, they are interested in how much they might be paying out. So let us see. So our X in this case will be the payout, which will be the payout by the insurance company, depending on whether the person survives the year, which is zero, or death, where they have to what? Pay $250,000. Well, if that is the case, can we build a probability model to summarize this information? Yes. Let us bring the first result out. There are a couple of outcomes here, either survival or death. And we have what? The corresponding value of X. In this case, that will be how much is the insurance company going to pay out if this 18-year-old survives the year? Well, as far as they are concerned, um, from the perspective of the individual here, it will be $350 if this 18-year-old male survives the year, and if the person dies, you have 350,000, then minus what? 250,000. This is from the pocket of the 18-year-old male here. So this is associated with what probabilities? The probability here, P of X, would be, in this case, for 350, if the person survives, the respective probability is 0.998937. Whereas, so take note that 350 minus 250,000 is negative 249,650. And the remaining probability definitely will be 1, since no probability exceeds what? 1, minus the remainder of the probability. So you have what? 0.001063. Okay? So what is the expected value of this policy from the point of view of the insurance company? Well, the expected value will be each value multiplied by its probability. So you have 350 multiplied by 0.998937 plus the next value, which is negative 249,650 multiplied by 0.001063, and that will give about $84.25. So this, as far as the payout from the pocket of what? The insurance company. Maybe for clarity, let me put this in this time. Let me say payout by the payer, by the 18-year-old male, by the 18-year-old male. Sorry about that. That will give it a little more what spice. And take note that whatever is being paid out by this 18-year-old male is what the insurance company will expect to make. So, what is the mean or this expected value? What does it mean? This means that on average, the insurance company expects to make expects expects to make $84.25 on each 18-year-old male it insures. And that takes us to what is the standard deviation of x? Standard deviation is always the square root of the variance of x. So we need to find this variance first. Well, the variance of x is the expected value of x squared minus the mean that we just got squared. So how would we get x squared, expected value of x squared? To find the expected value of x squared like we did in the past example, we would need to take each x squared value and multiply by the probability. In other words, 350 squared multiplied by, oops, let me see, I have that mixed up. You have x squared multiplied by p of x. We have 350 multiplied by 0.998937. And the next one will be negative 249,650 squared multiplied by 0.001063. So in which case, we'll get two different values. So for the values, for the first value here, I'm going to plug that in here. That will give me about 122,369.7825 plus the second value here would be 66366,876.94. That will be my expected value of x squared, and minus the expected value of x. That was the mean we got earlier, 84.25 all squared. Okay, and that should give us a value that is equal to, so the variance of x will be equal to 366.96.94. Oh, excuse me, I think I wrote that here. Right, so this should be 6625.160.5.22. Yes, and this would be the variance. I'll pull the variance back in here, and we can find the standard deviation. So the standard deviation will be the square root of 66366,876.94, which will give approximately 8146.59 in dollars. So this is the standard deviation. I can see that the standard deviation is a large number, which means there'll be a lot of variabilities in how much they will expect to get. So the standard deviation at $8,146.59 is very large, which means there will be a lot of variabilities in how much they stand to get from the payout from each insured 18-year-old. And so this shows it's very large, showing large variability. In order to bring a little bit more consistency and predictability to how much they will expect to make from each person, the insurance company, my recommendation would be that the insurance company should advertise intensively, should advertise to get more insured what? More insured members, if this idea is to work in the interest of the insurance company.